We're going to demonstrate how to carry out ion exchange chromatography. Here is the basic instrument you require to carry out an ion exchange chromatography. So this is a simple gravity column we use to purify small proteins. Okay, so this purification is not carried out in cold because the protein is quite stabilized. So if you want to carry out protein purification using ion exchange chromatography, you have to ensure that the environment is cool if your protein is not stable in room temperature, for example. For ion exchange chromatography, so you have a column. This is a column, a plastic column. You have a filter here, and the volume is graded along the size of the column. So you pack your resin or ion exchange resin inside this column, and then you also have a switch here. You can loosen or tighten the switch in order to allow the flow through the tubing. Here is a silicone tubing. You use silicone tubing to flow, to let the fluid flow out of the column. So when you pour in the buffer or your sample at the upper opening of the column, it will flow down the column and go into the what we call the waste or your collection tube. So when you want to collect your sample, you will have your collection tube ready to be collected. So you will collect your fraction here until you have enough fraction for a separation. For separation using ion exchange chromatography, you will have your resin or your ion exchange reagent, okay, that you use for separation. So in my case, in our case today, we use CM Sephadex. It's a cation exchange chromatography. We use cation exchange chromatography because the protein that we want to interested to separate is a positively charged protein, but the resin or the stationary phase compound that we use is a negatively charged. That's why we have carboxy-methyl cellulose. Here is a commercial name, CM Sephadex G25. Okay, and then prior to use, we need to swell or suspend the resin inside the buffer. So every resin need to be suspended inside the buffer. So it takes some time for the swelling to complete. So you have to wait. You have to wait until all the resin complete. Then you can start load your sample. We are packing the column. We are putting in the swollen resin or the stationary phase inside the column. We have to continue until enough resin is dispensed into the column, and while we putting in the resin inside the column, we have to wait until the resin resettle at the bottom of the column, until the volume of the resin enough to the required column volume that we need for our separation. In this separation, we prepare ion exchange column at column volume of approximately 5 ml. So you can see the volume 5 ml almost. So this is our CV or column volume. Okay, so while we preparing, while waiting for the resin to settle, okay, we can also open the outlet or the switch of the flow, okay, because to let the fluid flow through and to help settle with the resin. And also one precaution that we need to be remember each time we preparing a resin for ion exchange chromatography, we must ensure that the resin do not run dry, because you will damage your resin and you will also allow air to trap inside the resin. So we have to ensure that when we open the opening of the flow, we must be careful not to let the water level touch the resin, or don't let the resin run dry. So it's very important precaution. Buffer with no salt or zero concentration salt. So today we are using 3 CV volume. So 3 CV mean I use about roughly about 5 multiplied by 3, 15 ml. Okay, this is equilibration.
before loading the sample, it is essential to pre-filter the sample using 0.45 exchange filter hydrophilic, as you can see here. Okay. This step remove any particulate material to prevent from column clogging. This is how to filter the sample. So we have to measure 0.5 ml. Alright. To remove air bubbles. Load 20 ml of pre-filter sample into the column. Allow the sample to pass through slowly. So first we have to control the flow rate. Collect the flow through into the small Falcon tubes. The total flow through volume should be almost equal to the loading volume, about 20 ml. So next, we proceed with the washing step using buffer A. Pour 30 ml equivalent to 5 column volume at the top of column. Turn on the pump, let the buffer flow. Collect the wash buffer in small Falcon tube with 10 ml per tube. This helps remove any unbound or weakly bound substances. Elution is carried out in a stepwise manner using buffer with increasing salt concentrations to separate the bound protein based on their charge. So here we have a 5 buffer, which buffer A with 0 molar NaCl, buffer B 0.25 molar NaCl, buffer C 0.5 molar NaCl, buffer D 0.75 molar NaCl, and buffer E 1 molar NaCl. So first step is we put buffer A into the column, 10 ml, which equivalent to 2 column volume, which means our column volume is 5 and times 2. And next we switch on, and then we collect the fractions into 5 fractions, which are 2 ml each. So next we are going to do the same step for the buffer B, C, D and E. We pour 10 ml into the column, so and then we collect the fractions into the 5 small micro tubes. As the salt concentration increases, one body will elute of different steps depending on their affinity to the resin. After the elution step, rinse the column with a 10 ml of buffer E, equivalent to 2 column volume, to remove any remaining proteins. Finally, last but not least, we wash the column with 20% ethanol using 15 ml or equivalent to 3 column volume to disinfect and store the column properly for future use.